Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Last video, we made very good progress with the ASM matcher. We got it into a functional state. I couldn't see any more obvious bugs, but doesn't mean it's all super perfect now. But yeah, once there are some issues, then we can tackle them after the fact. Okay, there's one more thing I would like to improve, and that is the ticks, the string, the strings here in this class. Here, those are pretty sad to read. Okay, how can we make this better? Yeah. Okay, so FMT format. SCD string str format const. Okay, so it would be prefix of %s x and closing, right? And then s prefix of, and then address, right? Like that. Let's see. Let's put a breakpoint here. Let's hope it hits. Off for this. Yeah, seems to be okay. Let's call this format. Format.cstr. Okay, so here we would have prefix sup and then also x address, quotes, quotes, yeah. Okay. Format.cstr. Okay, here we have symbol.name, and that is also format.cstr. Yeah. Okay, next, let's do all the symbols if we can find them. Current documents. So it's this. Format. And here as well. Formats, okay. Okay, let's search for prefix off. Prefix off. Okay, so here we have offset sx of value, right? Yeah, I think so. Format.cstr. Here we have zup. Zup. Format.cstr. Okay, here we have another of. This is plus s of x value, yeah. Format.cstr. Here we have another without the plus, prefix of address, oh boy, value, string, address, yeah. Format.cstr. Okay, let's search for all the zups. Find all. Okay, so here we have a zup. Zup address sx, yeah. Format .cstr. Here we have plus zup, plus with value, format.cstr. And here we have a sub x offset format.cstr. And here we have plus. Here we have brackets, brackets, sx sub value format.cstr. Okay, and we have prefix unc. That's prefix unc value yeah, format.cstr, and we got this, that offset format.cstr. There we go. Okay, I think this is a little bit more the C++ way of doing things. Okay, so now the question is, if we have all covered, let's search for all. Let's see if I missed any. Find all. Yeah. Some more here. Let's copy this here as well. This is plus that. Format. Here we have offset. Format. And here we have that. Format, and here we have right, that's already covered. Yeah. Okay, I hope I made no mistake. It's easy to make mistakes, yeah. Yeah, I think that's fine. Okay, let's compile, not yet, function types. So we should now be able to remove these guys here. Unc of sub, and then remove these. Let's see. Okay, good. Let's compare. Let's run this once. Oh, it hit a breakpoint. Okay. And so it should have regenerated this, yeah. And so files, compare. Oh. Let's do the other. Huh. Why is this on this side? Like, hey? Like here it's on this side and here it's on this side. Why is this inverted? Can we swap this? I don't understand why it's this way. I really don't understand why it's this way. So basically, this is that, and this is that. We should have taken a snapshot before. Okay, there's a difference here. Log is capital now. Why is that? Log X. Okay. Okay, logs are back normal now. Push offset. Okay, here's an error. Offset. Okay, so we made an error somewhere here. This is sub of symbol, sub of sub of sub of sub unk sub unk. Huh? I don't see the error. one of the offset guys. Offsets. Ah. I don't see my mistake. I don't understand this. Maybe this is correct actually. Sup. Let me see. Search for this. No. What if we search for this? Um, okay, I don't know what this is. Okay, so this mem move thing here, I think these things happen because we use... It's okay, we leave it for now. I know where this comes from. So this one is the name that we get from the executable, and this is the name that we get from the PDB. So if you would say, hey, don't overwrite executable names with the PDB names, then we would get this one here on the side. So we could do that, but for now, let's leave it. Yeah, because EDR also has shown these names here instead of this. So we can decide later which name it should be. Okay. Then let's try to commit our things. I think we should have two submissions. One for the various changes we did here with function. Here we have still some commented out stuff. I think this to-do comment we can actually remove. If I'm not mistaken, because we actually use this now, right? Yeah, actually we need it because yeah, we probably need it for something. Let's remove this function intermediate. Okay, this pseudo symbol result we also don't need. Okay, so we take this, we take this, and we take this stuff, and this. Yeah. Then we take util. What is util used for? Util strip, right? Strip code. Okay. Sx sub, yeah, of x name. Plus sub x prefix sub plus of x offset as symbol name. Offset sub value. Okay. Offset of value. Okay. As symbol. Okay. Sub x sub offset. Yeah. Okay. Unc offset. Okay. Bracket quote s. Yeah. Okay. And here bracket quote sub value x. Okay. And unc s x unc value bracket x seems to be okay. Good. Label count. Here we do this. Yeah, I hope this is not too expensive here, but yeah, if it's a concern, we can look at this. Pseudo symbol, if that, yeah. Reserve, yeah. Instruction ASM label and place back. Yeah. ASM instruction is valid. Is invalid, true. Yeah, ASM text. Else all this. Which I hope is all correct. Yeah, I changed the indentation here. Okay. And here add pseudo symbol, return false, yeah, and then if is not end. So if it already exists, return false, and otherwise it adds it true. Yeah. Okay, this looks good. Function types, here we added array, yeah, and string view. Yeah, this looks correct. Here we fixed the header. This one we don't change yet. Actually, oof. Yeah, we need to change this thing here. Yeah. Runner. Okay, util. I think these ones we also need to stage. And these as well. Okay, I think that's it. Okay, so what did we do here? What did we do? We changed the split ASM split instruction data into ASM instruction and ASM instruction label to use in variant. And we also add quotes around all symbols. Add quotes around all symbols. Add quotes around all symbols in intermediate for internal use. For processing. Add quotes around all symbols for processing purposes. And change Cyan string, use fmt lib for Cyan string format. Yeah. I think that's it, right? Oof, it's quite a lot. Okay, split instruction data into AS instruction and instruction lays into use invariant. Add quotes around all symbols for processing purposes. Use fmt lib for Cyan string formats. Okay, let's commit this guy. Then we stash what we currently have on top of this, and we compile this and see if it compiles as standalone, which I hope it does. And I think it does, but I could be wrong. Thank Jesus. It compiles. Let's press F7 one more time just to make sure. Yeah, okay, that looks good. Okay, then stash pop. And we compile once more. And it compiles. Okay, good. Then let's see, yes. Bits representing positions. Okay. Well, there's not much going on in here, but okay. Oh, here we have some comments. Of that. What is this here? Huh? Where are the numbers? Weird. Okay. ASM match clang format off. Well, I wonder we should keep this for this common format for our functions. We've used it in many other places, but it's kind of weird. Oof. Whatever. Okay, this looks okay. Here's a matcher. Okay, at last I see. Yeah, we have a lot of asserts in place to help us find the way. I wonder if we should maybe rename this to C0, since we also call this C down here somewhere. Here. C0. Yeah. Has Jumlen mismatch. Text info is mismatch. I think this way. No, this has to be. Yeah. Yeah. Yeah, it looks okay to me. Ah, there's one more thing. This reserve thing. Let's see if the reservation is good. Let's put a breakpoint here and down here. So we reserve 489 and we will have 511. Oh. I think that's because we have situations where the label is on different sides. Yeah. So this way over capacited. Yeah, that's not good. Yeah. Yeah, I see why this happens. So if a function is a perfect match, then obviously this won't happen. But if there is a scenario where you have mismatches between the functions, and then on one side you have a label and on the other side you don't have the labels, and we add additional labels in between these things. Instructions count. We would have to. So either instructions, get instructions. Well, what we could do is I have an idea. We can, in our function, we have our instructions here. We can add additional data. We say un32t ASM instruction count equals 0, and we do ASM label count, or you just call it instruction count and label count. Yeah. Instruction count and label count. So basically these together should make up this size, right? So let's go to our function here. So here we say instruction count plus instruction count, and here we say plus plus label counts. Label. Huh? Oh, it's not m. Now it is. M label counts. Oh, hold on. We have different naming convention for these. Oddly enough. Label counts. Yeah. Okay, so instruction counts. Instruction count. Let's put an assert instruction count equals instruction count, and I'm not sure if label count is supposed to match this label count. I don't know. Maybe, maybe not. Not sure. We'll see. Could be that this doesn't match, but this I think would definitely match. Well, we will see. Okay, so we have these. Let's see. So we have this instruction index, yeah. Instruction count equals that, label count. It's not the same. Why? So this is one less, but why? I don't know why. It's not the same. I'll remove that. If that's the case, we should also remove that. Then let's simply check the following. Instructions dot size should equal instruction count plus count. Static cast size t. I think these will match. Same. Oh, doesn't. Oh, label count. Sorry about that. Let's try again. There we go. Okay. And then what we can do now is we can qint32t get instruction count, get instruction count const and get label count. For all these getters, do we really need these things in the CPP? Don't think so. Let's do it here. Return m instruction. That was simple functions. Return m begin address. Return end address. Instruction count. Label count. And then we can remove the duplicates here. Get this and get those. Okay, and now with this information, we should be able to do the following. We go back to our ASM matcher. So we have here instruction counts, and what we do is get instruction count, get instruction count, get instruction count, get label count. 0, 1. Okay, then we do here const size t. Let's do let's put this guy down here. Let's do EC0 and IC1 and LC0. Well, it's hard to read. Let's do label label count. Let's write it out. Avoid confusions. Label count 1. Inst count 1. Inst count 0. Good. So the logic now is that we say max const size t label count combined is that plus that, and then we say this instruction plus label count combined and inst inst count one plus this. Let's add a comment here. Well, let's make it const size t max size, reserve max size. This is over reserving. This is over reserving with label counts on both sides, because in worst case mismatches, the labels will be strided. Strided, is that a good word? Will be unaligned on. Will be unaligned, and this is over reserving with label counts on both sides, because with worst case mismatches, because the labels will be unaligned, in worst case mismatches. This is over reserving the label counts on both sides, because labels can be unaligned in worst case mismatches. Over reserves with label counts, over reserves with both label counts on both sides, because labels can be unaligned in worst case mismatches. Okay, I hope that explains it. So the idea is that, yeah, we can have unalignment with the labels, and that means that the mismatch will be grand and the labels will be all over the place. So we'll have a lot of places where these incur additional lines that we need to account for and reserve. And since I don't want to go into the situation where we over reserve too much, aka like if we reserve too little and then we push back and we go over the limit, the vector will grow much higher than what we likely need. So this strategy, I hope, will over reserve, but just a bit consistently and not too much. So that's a hope here. Let's see. So we have label count 7, 34. Okay, so it should now over. So it's 41. So it will go, yeah, 41 on both sides. Max size 496. Okay. So now we should only at max have 496 elements at the end of it. Let's see if that is true. Shit, we have more. Well, that didn't work well. Okay, well, why? Why is it more? Probably because since we have this look ahead thing, there can be scenarios where we look ahead on one side, so we incur, we skip ahead. Wait. Yeah, I think it's because of the null entries here, the dummy instructions we insert. These then take space. Yeah. I think it's because of that. Oof. Oof. Can we deal with this somehow? Shit. I don't think so, because it's highly dependent on the mismatch, which we don't know beforehand. So I think the only thing we can do here is guess. So on top of that, reserves additional space to account for reserves additional space over reserves with both label counts on both sides, because labels can be unaligned and worst case mismatches. On top of that, null, top of that, empty entries can take up space on either side, so add a guess margin. So let's do max size equals max size times 1.2, perhaps. Size t double and size t. Yeah, this is a bit unfortunate, but I don't see any other way. Like the way we organize the data, it is just like that. There is guesswork, right? Because we don't know in advance the mismatch count. So yeah, let's see if this gives us some good results. So we have 496, and now we do 595. Which is still smaller than the 700 something we had before, right? Let's see. So now we have, yeah, we are under the limits. Let's see another example. 36, and we have 28, because they all match perfectly. 67, 51, 13, 9, 39, 32. Okay, how about let's make a test. Test size t reserved. Jesus, reserved reserved equals max size. And here let's do put a breakpoint if result dot lines dot size is larger than reserved, then let's do a printf xx. Yeah. Let's put a breakpoint here and let's see if that hits ever. If it doesn't, we can maybe make it a little bit smaller. We are just guessing really. Let's see. Okay, it does actually hit. Reserved 130 and we have 132. Okay, that has a lot of mismatches here. Yeah. Okay, so it can still be worse. Yeah. There's another. Okay, 3. Okay. So maybe we should even make it larger. Well, I don't know. We don't have to hit everything, right? If some still over allocate, then so be it. Yeah, I guess 1.2 is okay for now. Yeah, let's go with that. It's always good to have perfect reserve or perfect resize of the data to not waste any space. But here it's difficult to anticipate. We would have to make 2 passes, but then it's expensive. Yeah, then in that case it would be cheaper to just shrink to fit at the end of it. But I don't think we necessarily need that. Only if we really need to save on memory, then we need to shrink more aggressively, but that will also be computationally more expensive. Okay. Over reserves dispose label counts on both sides because labels can be unaligned and worst case mismatches. On top of that, empty entries can take up space on either side. So add a guessed math. So this adds a guessed margin. Okay, but as long as we avoid most reallocations, I guess that's good enough. Yeah. All right. Good. Yeah. If I didn't make a mistake, then this is a good starting point. Yeah. Okay, let's submit it as implement first version of ASM matcher class with look ahead functionality. First version of ASM matcher class. Implement fully functional first version of ASM measure class with look ahead functionality. Collection bundles, collection. What is this here? Resize 1? Credit dummy, right? Credit dummy. Bundles. Okay, cool. Okay, this is looking very promising. Okay, this looks good to me. This is empty. Yeah. I think we are good. Okay, let's commit this guy. Stage. Commit. All right, good. Let's compile this once more and run it once more. Let's see if it really actually runs and doesn't just crash. Works. Okay. Good. If program compiles, then it's 30% great. If it then also runs without crashing, 60% great. And the last 40%, if it's actually correct and so on. Yeah. Good. Then we can push this to branch. Yeah. Good. Let's give a status update on that thing. ASM first functional ASM matcher implementation of first functional ASM matcher is complete. It does have look ahead functionality to try match things, to try match lines with offsets as well. To try match lines, at different positions, match lines, different positions on either side as well. It does things correctly as far as I could see in debugger, but maybe there are some minor bugs. But maybe there are some bugs that I did not yet see. Next step, I will make it generate matching reports as text files, so we can look at it, and then afterwards can think about UI for it and other things. overbugs. Good, so that's the status update, and yeah, I think that came along pretty nicely. Pushed to branch. Push to branch. Good. Yeah, then next video we will try to implement text output for the, what do we have? For the comparison result here, we can then use this to generate text output, and then we can look at that, see if there are any issues left that we need to fix, and then yeah, as I wrote, then we can think about adding a UI for this to make it nice to use, because using command line and then opening files to inspect, that's a little bit cumbersome, right? Good. Then yeah, I hope you enjoyed. I wish you a great day or night. Until next time, goodbye.